Good morning, students. Today we are going to study about the third method of improvement of TCP in mobile or wireless networks. So the third method that we are going to study is Mobile TCP, also known as MTCP. Now we know that packets can be lost in wireless networks during handovers or due to higher bit rates. Okay. Also, packets could be also lost to another reason that is common in wireless networks, and that is disconnection. Quite often, mobile users may not be able to connect at all. Okay. For example, you know that in a particular building, sometimes at some points or some floors have better range than other floors. Certain parts of the building may not have any range at all. So what is the reaction of standard? Okay, by standard TCP, I mean TCP in wired networks. What is the reaction of standard TCP to disconnections? So standard TCP, in a standard TCP, a sender would try to retransmit the data by using a retransmission timer that would double with each unsuccessful retransmission attempt. So you would try retransmitting maximum of 1 minute depending on the initial value of the round trip time. So the sender would try to retransmit unacknowledged packets every minute and will give up after trying for 12 retransmissions. So you can just read on this slide what I just said. This is the way a standard TCP or your wired TCP would try to react to a disconnection. Suppose you were using indirect TCP and the mobile had to disconnect, then the proxy, that is a foreign agent, would have to use a larger buffer in order to buffer all the packets that are coming. So the longer the disconnection, the larger the buffer it would need. Similarly, if you were using snooping TCP and a disconnection would occur, then the mobile would not be able to send acknowledgements and the snooping would not help. The foreign agent would not be able to snoop the acknowledgements and therefore it won't be able to do fast retransmissions. So they came up with another approach known as the mobile TCP to deal with disconnections. So it is to mainly deal with disconnection, a better approach to mobile disconnections. The problem of losing packets due to disconnection. Okay, it would handle all the other problems also, but also it would handle the problem of disconnections better than the standard TCP, the ITCP, and the snooping TCP. So the main idea behind mobile TCP was to prevent the congestion window size from shrinking. So it would try to maintain the congestion window size before the packet loss. So MTCP would try to improve the overall throughput, lower the delay, and maintain the end-to-end semantics of TCP. And also it would attempt to provide an efficient handover. And like I told you, MTCP has been specially designed to handle frequent disconnections. So basically, how does the MTCP work? So the MTCP works the same manner as ITCP. It would split the TCP connection into two parts. So an unmodified TCP would be used between the standard host or your correspondent host and the supervisory host. Now in MTCP, call the foreign agent as the supervisory host. Okay. So remember the use here. Standard host stands for the correspondent node, and the supervisory host stands for the foreign or FA. So between the correspondent node and the FA, that is your supervisory host, you would use the unmodified TCP. While we would use an optimized TCP on the wireless side. So you would connect the FA, which is also known as the supervisory host, to the MH, the mobile host, with an optimized TCP. So this works in the same way like your ITCP. Okay, let's just look at the ITCP diagram so that you remember the ITCP. This is your ITCP diagram here. So in your MTCP, we are calling the foreign agent as your supervisory host. Okay, and the correspondent node is known as the standard host. So they are connected to each other through the wire and through the standard TCP. Similarly, your foreign agent, or in other words supervisory host, is connected to mobile host through a optimized TCP, just like ITCP. Okay, so it splits the connection into two parts. But in ITP, end-to-end connection or end-to-end semantics is lost, whereas in MTCP, the end-to-end semantics is maintained. We'll understand how the mobile TCP maintains the end-to-end semantics. Okay, let's go and look how MTCP works. So the supervisory host, that is your FA, is responsible for exchanging data between both the parts, just like your ITCP FA. Okay, but in MTCP, the MTCP will assume that there is a less error rate on the wireless side. Therefore, the FA of the MTCP, FA meaning supervisory host in the MTCP, does not perform caching. Okay, it does not perform caching, or it does not retransmit the data. Okay, it does not perform caching or does not retransmit the data. Okay, here the word should be caching. So if a packet is lost on the wireless side, then the packet has to be retransmitted by the original sender. So because the packet is being retransmitted by the original sender, it maintains the end-to-end semantics. So let's just take a diagram and let's see how it works. So there's your supervisory host. Supervisory host is nothing but, like I told you, it is the FA. Okay, foreign agent. It is connected by a wired TCP to your correspondent node. This is your correspondent node. Okay, this is your FA or your supervisory host, and it is connected by wireless connection to your mobile host. So here you are using standard TCP. Here you are using optimized TCP. Okay. Now the difference between the MTCP and ITCP is, these are the similarities. Okay. The difference is, in ITCP, if a packet was lost, the retransmission was done by the FA. So the retransmission was done by the FA. Okay. But in MTCP, let me just rub this. But in MTCP, if a packet that is flowing from the correspondent node to the mobile host is lost, okay, the FA will not retransmit the data. but the original sender will retransmit the data. So therefore, although there are two connections here, this maintains the end-to-end semantics. Also, the acknowledgement that is sent from the mobile host to the correspondent node. So the FA is not responsible for retransmitting any data that is lost. So this is the major difference between ITCP and MTCP. In MTCP, the end-to-end semantics is maintained. So I hope you have understood. So what is the responsibilities of the supervisory host or your FA? So the FA or your supervisory host monitors all the packets sent to the mobile host, and it also checks all the acknowledgements that are returned from the mobile host. If the supervisory host does not receive the acknowledgement for some time, then it will assume that the mobile host is disconnected. Like we have discussed, MTCP has been optimized for mobile disconnection. Okay, so if your FA in the MTCP does not receive any acknowledgement from the mobile host after some time, then it will assume that the MH or your mobile host is disconnected. So whenever it assumes that the mobile host is disconnected, the next step that the supervisory host takes is it chokes the sender by sending a packet, okay, and it sets the window size of the sender to 0. Okay, it sets the window size equal to 0 of the sender. So when you set the window size of equal to 0 of the sender will go to a persistent mode. Okay, persistent mode means the state of the sender will not change. The state of the sender will not change no matter how long the receiver remains disconnected. So in simpler words, the sender will be paused. Okay, the sender will be paused. So the moment, again I'll repeat, the SH monitors the packets in both the directions. It monitors all the packets sent to the MH, and also it monitors all the acknowledgements returning from the MH. If the FA does not find the acknowledgements coming within a certain period of time, then it assumes that the mobile host is disconnected. So the moment it realizes that the mobile host is disconnected, the next step the FA does is it chokes the sender by making the window size equal to 0. Okay. So the moment the window size is set to 0, the sender will go to persistent mode. So in persistent mode, meaning the state of the sender will not change. Okay. And the sender will not try to retransmit any data. So as soon as the supervisory host detects the connectivity again, now the supervisory host can be the same supervisory host or a new supervisory host. Suppose the mobile is gone to a new network. So as soon as the supervisory host detects the connectivity again, it reopens the window of the sender to the old value. So whatever was the old value of transmission of the window size of the sender, that value will be restarted. So this is how connectivity will be established again, and data speed or the data transmission will happen at the same original speed as before disconnection. So like I told you, the sender can therefore continue sending at a full speed. This mechanism of MTCP does not require any changes to the sender's TCP. The wireless side uses a slightly modified TCP that can recover from packet loss much faster. So therefore, since we are choking the sender, this modified TCP does not use slow start. Okay, but MTCP may require a bandwidth manager to implement fair sharing over the wireless link. So the advantages of MTCP are the following. It maintains the TCP end-to-end semantics. Okay, because the supervisory host does not send any acknowledgement itself, but it only forwards the acknowledgements that are being sent by the MH. Then, if second advantage, if the MH is disconnected, it avoids the frequent retransmissions. So the sender is choked, and therefore slow start is avoided. And then third advantage is, since it's not buffering any data, it's not necessary to forward the data to a new supervisory host. So there's no need to forward any data, buffered data, to the new supervisory host. Lost packets will be sent automatically by the sender to the new supervisory host. Disadvantages of MTCP are: MTCP assumes low error rates, which is not always valid. Okay. Similarly, a modified TCP on the wireless link requires some new network elements like bandwidth manager. So this is all about MTCP. I hope you understood how MTCP works to avoid slow start and to and avoid slow start by choking the sender, so that the sender does not do retransmissions, and then the sender can resume sending at the old speed as soon as the connectivity is established. So thank you for listening, and see you for the next lecture.